I'm back with some more verifying trig identities problems. This one is similar to the last one we did on the last video, and that is sine over 1 plus cosine x plus 1 plus cosine x over sine x equals 2 cosecant x. If you look at the last one we did from the last video, which is up here, I just continued right on. Let's see here. You'll see that this problem, it's pretty similar. It's like upside down. So let's see if we can remember what we should do here. Okay, so one of our tips that we wrote on the board, that one of those last days we were actually at school, we have two fractions here. I have a one fraction and another fraction, and this equals 2 cosecant theta, which is one term. If I have two fractions and I wanted to get it to equal one term, I'm going to have to put these fractions together. There's no way around it. So, I think I did this last time too, where I put this stuff too close to the side. I gave myself no room to work. Like, what am I doing? Wasting paper or something? Haha, it's not even paper. Okay, so let's look here. I'm going to have to get a common denominator. And these denominators have nothing in common. So this first fraction is 1 plus cosine x on the bottom. And the second fraction is sine x on the bottom. So I'm going to take this sine x, and I'm going to multiply the top and bottom of this first fraction by sine x. And then I'm going to come over here to this second fraction, and I'm going to put 1 plus cosine x. I'm going to multiply the top and bottom by that, but this is still in the way, so I'm going to move this over here a little bit. There we go. So I'm going to multiply the top and bottom by the second fraction by 1 plus cosine x. And I can do that because it equals 1. Okay, so we're going to simplify the tops, but we're not going to worry about the bottoms. So the top of the first fraction will be sine squared x. And the bottom of that fraction, we'll just leave it as sine x times 1 plus cosine x. We won't distribute in that sign or anything because that'll get yucky. Now, this, on the other hand, will have to get FOILed. If you remember, we had to do that last time as well. So if you FOIL that, that's going to be 1 plus 2 cosine x plus cosine squared x. And all that is over sine x times 1 plus cosine x. Okay. So the point in getting a common denominator, of course, is so that we can actually put the tops together. So I'm going to do that in this step. This is a step you could skip the blue step and the purple step. You could just combine that into one step. If you feel comfortable, don't skip too many steps, but I think you could probably skip that one. And this is all over sine x times 1 plus cosine x. So now let's look at the top and let's see if we can do any cleaning up. Do you see this? We talked about this last time. Look here. I see a sine squared x and I see a cosine squared x, and they're added. Look at that. Even though they're far away, it doesn't matter. They're still being added together. So what do these two equal? They equal 1. Again, it's almost like I planned it. Okay, I'm going to move this again. I keep writing too close. Oh, whoops. That's unfortunate. Look at that. I dragged this little guy with it. Let's put him back. There we go. Okay. So this and this, that equals 1. And I can put this one here with this one for a grand total of 2. So 2, so that's, you know what, that's a lot. I should probably not do so much in one step. Okay, so I'll just leave this, the 1 up here. So I'm changing my sine squared plus cosine squared into 1, plus the 1 that was already there, plus 2 cosine x, all over sine x times 1 plus cosine x. Yeah, I think I was trying to do too much at once. Okay, so the 1's can be combined into 2. So 2 plus 2 cosine x over sine x times 1 plus cosine x. And now we're at that same step from the last problem. We can factor a 2 out of the top. And look at what we have there. Those can cancel. Isn't that nice? Then we have 2 over sine x. And that equals 2 cosecant x. And that is what I was trying to get in the first place. All right. Okay, this next problem we're going to do uses a tip that is on our list that we made last week, but I don't think we've actually done one like this. And this is using conjugates. Conjugates, we usually use them with either imaginary numbers or square roots. A conjugate is something like this. If we had 1 plus square root of 5, then the conjugate would be 1 minus square root of 5. Or 3 plus 2i, his conjugate would be 3 minus 2i. Okay, so you can apply that same idea with trig functions as well. So what makes 2 pairs conjugates? It's the sign in front of the root that changes, the sign in front of the I that changes, or in our case, it'll really just be the sign that's in the middle. Okay, so here's our example. Sine x over 1 plus cosine x. This looks familiar, doesn't it? Equals 1 minus cosine x over sine x. Now, as tempting as it might be here to cross multiply, remember that you are not allowed to manipulate both sides. You can only manipulate one side. So that's very important. Okay, here I've gone again and not given myself enough room. I'm sensing a trend here. I'm just going to move this to the middle. Okay. Now, when I look at this, I am really not coming up with a lot. I look at this left side. I can't split it up into 2 fractions because there's 2 terms on the bottom, so that doesn't work. I could do that on the right, although I'm not really seeing how that's going to help me in this situation. And so this is one of those times where trying a conjugate might work. So let's look at this left side here. And we're going to multiply the top and bottom of this fraction by the conjugate of the denominator. Now notice the purple matches because you can only multiply the top and bottom of a fraction by the same thing. Normally I would say simplify the top, but you know what? I'm not going to this time. It might be unclear whether you should or should not. It's kind of hard to tell. Okay, so this, the bottom here is going to have to be FOILed. But the good thing about multiplying by a conjugate is when you do that, the middle terms of FOILing always cancel. So the outers and the inners cancel. And that's true anytime you're multiplying 2 conjugates together. So if we were to FOIL, I would get 1 times 1, which is 1. I would get 1 times cosine x, which is cosine x. I would get negative cosine x times 1, which is negative cosine x. And finally, I would get negative cosine x times positive cosine x, which is negative cosine squared x. But look what happens here. What happens? Gonzo. So I didn't really need them in the first place. So if you know you're multiplying by conjugates, you can actually just skip that step and just multiply the first and the last and call it done. Okay, so now I have this. Now recall from a few of our last problems. What does this equal? This equals sine squared x. Okay, you gotta put a star around this. It's easy to miss. Okay, so now I have 1 minus cosine x times sine x on the top. But now I've changed the bottom from 1 minus cosine squared x to just sine squared x. What can happen now? Do you see what can happen? That is a weird color yellow. I have a sine here and I have a sine squared here. Can I cancel this sign with one of the ones on the bottom? I sure can. So the sign on the top is gone, and now on the bottom I only have sine x. I don't have sine squared x anymore. And I believe this is what I was trying to find anyway. I feel like I've said that about 100 times. I gotta come up with a new line here. Look at that. They match. Gotta have my smiley face. Makes me happy. Sometimes I feel like Bob Ross on here with all these colors going, it makes me happy. Okay, so now I have one I want you to try. It's very similar. Hopefully you're catching the drift here of what we're doing. I do one, you do one similar. Okay. Cosine x over 1 plus sine x equals 1 minus sine x over cosine x. So take a look at what we did in the previous problem and see if you can apply that to here. So what I want you to do is I actually want you to pause the video and try to do this problem. And if you get stuck, turn the video back on. Okay, so we're going to multiply. I'm going to work on the left side. So I'm going to multiply the top and bottom of this fraction by the conjugate. I'm going to leave the top kind of as it is. And the bottom, remember I'm multiplying conjugates, so the middle terms are always going to cancel. So I'm going to wind up with 1 minus sine squared x. And I mean, FOIL it out if that makes you happy, but the middle terms will cancel. And just like what happened in the last problem, 1 plus sine squared x equals cosine squared x. Do you see how this is very similar to the previous problem? I can cancel this cosine with the cosine squared. And there we go. Remember to make your last line look exactly the same on the left as the right. Okay, and we'll do, I think we'll do one more example for today, and then we'll call it a day. Okay, this one's different. We have tangent x minus sine of negative x. And all that is over 1 plus cosine x equals tan x. So this is one of the first identities we wrote down. I'll put a line in here because that's a little confusing. And you have written down in your notebook somewhere that sine of negative x equals negative sine x. So that's going to take that minus sign and turn it into a plus. Okay. My personal thoughts now are to try to change the tangent into sines and cosines, because I really can't come up with anything else right now. So I'm going to take this tangent and I'm going to change that into sine x over cosine x, one of my old identities. As you're probably understanding, the problems are getting more sophisticated as we go along. Okay, so now I have sine x over cosine x plus sine x, and all that is over 1 plus cosine x. So I'm going to try to put this numerator together by getting a common denominator that's in the numerator, because that's not confusing. Okay, so I'm going to put a cosine on the top here and on the bottom here. So now the top looks like sine x plus sine x cosine x over cosine x, and all of that is over 1 plus cosine x. I'm hoping that this right here looks familiar to you. This is like the one we did in the beginning of the video. And that is that I can factor sine out of the top. And I'm going to get 1 plus cosine x over cosine x. And all that is over 1 plus cosine x. Now this is a complex fraction, which are pretty annoying. So I'm going to change this so that I'm multiplying by the reciprocal. So I'm going to keep the top of the numerator the same. But instead of dividing by 1 plus cosine x, I'm going to multiply by 1 over 1 plus cosine x, and I hope you're going to see what happens here. I can cancel these. Oops. Just wanted a different color. I can cancel this with this. Now I have sine x over cosine x, which equals tangent. And I am done. Oh, there's smiley face, because that was a hard one. Okay, I think that's enough for today. You should try some homework.